Hello everyone. In this video I'm going to discuss about solution of non-homogeneous linear differential equation when q of x is of the form x power m into v of x. Here m is a positive. Now we'll discuss how to find solution. Generally we write solution as complementary function plus particular integral. In my earlier videos we were discussed how to find complementary function. Now today I'm going to discuss about how to find particular integral when q is of the form x power m into v. When q is of the form x power m into v, we write a particular integral as like this is the formula to find particular integral when q is of the form x power m into v. The formula says that x minus 1 by f of d into f dash d into 1 by f of d into v of x. Now this is the formula to find a particular integral when q is of the form x power m into v. M is a positive integer in this case. Now this formula can be applied repeatedly when m is greater than 2. If m is equals to 1, we can apply very easily. If m is 2, let us say 3, 4 and so on, in that case we need to apply this formula repeatedly to find particular integral of this one. Instead of applying this formula repeatedly, even we can use a general method. Even I am going to discuss that method now. Let us discuss an example. Solve d square plus 2d plus 1 y equals. Now this is the given problem. Now clearly it is a linear differential equation. It is a second order linear differential equation. Clearly it is a non-homogeneous linear constant coefficients because right hand part we have x into cos x. It is of the form power m into v. Here v is a function of. Now let us discuss solution of this one. Find solution of this one. First we need to find complementary function. We have to find complementary function by taking right hand part as 0. Let us write what is the given differential equation. The given differential equation can be written as like this. The given differential equation is d square plus 2d plus 1 into y equals to x cos x. Can form d in y q of where f of d equals to d square plus 1 q of x equals. To find solution of this one, let us find a complementary function of this one by taking right hand part as 0. So, for that first we need to find auxiliary equation. Auxiliary equation is given by f of m, that is nothing but m square plus 2m plus 1 equals 0. It is a quadratic equation m. Try to solve this equation. By solving this equation we get m equals to minus 1 and minus 1. Clearly the roots are real and repeated. Now let us write complementary function of this problem. Complementary function is given by c1 plus c2x in e power minus x. Now this is the method to write complementary function when roots are real and repeated. Now let us find a particular integral. Now pi equals 1 by f of d into q. Here f of d square plus 2d plus 1 and q is x into cos. Now q is of the form x power m into v. It is of the form q equals to x power m into v. V is any function of x. In this case v of x equals to cos x. Here v of x equals to cos x. M equals to 1. To find particular integral of this one, we can use either formula or we can use general method. Now let us discuss the solution by using the formula. The formula says that x minus 1 by f of d f dash into 1 by f of d into v of. This is the formula to find a particular integral when q equals to x power m into, here m equals to 1 and v is cos x. Now here f of d is nothing but d square plus 2d plus 1. Let us simplify this one. X minus 1 by d square plus 2d plus 1 in its derivative is 2d plus into 1 by d square plus 2d plus 1 into cos. First we need to find particular integral of this part. After finding particular integral of this part, we can simplify to get particular integral of the given problem. Let us find particular integral of this part. I am taking this as pi1 x minus 1 by d square plus 2d plus 1 into 2d plus. Let us take this as pi1 to understand easily. Integral 1. Let us find pi1 separately. Then let us simplify this. Now pi1 equals to 1 by d square plus 2d plus 1 into cos. Now we want to find particular integral of this form. clearly it is of the form cos ax by f of d. Now we use one of the previous methods to find particular integral of this one. In this case, we put a d square equals to minus of a square. Here cos x is there, a equals to 1, so d square equals to minus 1. Now wherever d square is there, write down minus 1. It becomes 1 by minus 1 plus 2d plus 1 into cos. Plus 1 minus 1 can be cancelled. We get 1 by 2d into cos x. 1 by d means inverse operator. This is called inverse operator, or you can say integral operator. 1 by d means integration. Integration of cos x is sin x. So let us write here 1 by 2 sin x. Now this is a pi1. Now substitute this one here. Then we try to find particular integral of the given problem. Now let us substitute that here. Pi equals to x minus 1 by d square plus 2d plus 1 into 2d plus 2. Here pi1, that is 1 by sine. Now let us simplify this one. You take this inside of this square bracket and simplify. We get 1 by 2 times x sine x minus 1 by 2 times 1 by d square plus 2d plus 1 into 2 times d plus 1 sine. I am taking this 1 by 2 sine x inside. X into 1 by 2 sine x, that is 1 by 2 x sine x. Now here I am writing this as it is. 1 by 2 I am writing here. Sine x I am writing. This 2 can be cancelled. We need to simplify further. 1 by 2 x sine x minus 2 can be cancelled. 1 by d square plus 2d plus 1 into d plus 1 of this sine. Now let us find the PI of this part. Let us find PI of this one. Now PI of this one can be find using one of the previous methods. Now here q is sin ax, a is nothing but 1. The method says that put d square equals to minus of a square. Here a equals 1 sin ax, so minus 1. Wherever d square is there, write down minus 1. So you will get 1 by minus 1 plus 2d plus 1 into sin x. Minus 1 plus 1 can be cancelled. You will get 1 by 2d sin x. 1 by d means integration. Integration of sin x is minus cos x. So you will get minus 1 by 2 cos x. Now this is pi of this part. Now you substitute that here. You will get x sin x minus d plus 1 times. We get minus 1 by 2 cos. Again further simplify. 1 by 2 times x sin x minus become plus 1 by 2 times d plus 1 of cos x. D means differential operator, derivative. 1 by 2 times x sin x plus 1 by 2 d of cos x plus cos. D means derivative of cos x is minus sin x. Let us write that here. Finally we get 1 by 2 x sin x plus 1 by 2 minus cos x plus minus sin x. Now this is the PI of given problem. 1 by 2 times sin x plus 1 by 2 cos x minus sin x. Now this is the PI of the given problem. Now general solution of the given problem is given by complementary function plus particular integral. Now I'll write general solution. Required general solution of given problem is y equals to complementary function plus particular. Complementary function is c1 plus 2x into e power minus x plus particular integral is 1 by 2 times x sin x plus cos x minus sine, where c1 and c2 are arbitrary constant. This gives the general solution of the problem. Now this is the way to find solution of the given differential equation when q is of the form x power m into v. Here m equals to 1. So we have applied this formula to find solution of this problem. Let us see if m is greater than 1. In that case, we need to apply this formula repeatedly to find solution of the problem. Instead of applying the formula repeatedly, we can use a general method. So let us discuss general method. General method says that when q of x equals to x power m into v, where v is a function of x, particularly we take v as either cos ax or sin ax. Now the general method says that we know e power ix is nothing but cos ax plus I sin ax. So cos ax is nothing but real part of e power iax. Sin ax is nothing but imaginary part of e power ia. We replace cos ax with real part of e power ax, sin ax with imaginary part of e power ax. Then we'll try to find particular real using one of the previous method. Let us discuss the same problem using this general method. Solve d square plus 2d plus 1 into y equals x into cos. Now instead of applying formula, I'll apply the general method. Now we'll discuss how to find solution using general. Now finding complementary function is same, so I'm not explaining that one. Just now we've discussed how to find complementary function, so I'm writing straight away. Complementary function of this problem is c1 plus c2x into e power minus x. This gives the complementary function. Now pi equals to 1 by f of d into q of x. In this case, f of d is d square plus 2d plus 1. Q of x is x cos. Now we will use general method to find particular deal of this problem. Instead of using formula, we use general. General method says that we have to replace cos x with a real part of e power ix. Now wherever cos x is there, write down real part of e power ix. So 1 by f of d into, in place of this cos x we write real part of e power. This can be further written as real part of 1 by f of d x into e power I. Now look at the problem. It is of the form 1 by f of d into e power ax into some v. Previous video we were discussed how to find particular deal of this problem. In this case, the method says that it is like this. It is of the form q equals to e power ax into v. In this case, method says that we replace d with a d plus a in f of d. Then we'll try to find particular integral. In this case, a is nothing but I. So here we replace d with d plus I. Find this one. After replacing, we write this e power ix aside d plus I into x. Now what is f of d? F of d is nothing but d square. Here f of d is nothing but d square plus 2d plus 1. Now this is nothing but d plus 1 whole square. In place of d, write down d plus I whole square. Now let us simplify this one. Real part of e power ix into 1 by d plus I plus 1 whole square. Now again it is of the form q equals to 1 by f of d into x power m form. Now in my earlier video we were discussed how to find particular integral when q is of the form x power m into 1 by f of d like that. So we use that method to find particular integral of this one. In that method we used to take a least degree term outside and we have written in the form 1 plus some function of d like that. So let us discuss using that method. Real part of e power ix into here 1 by, this is constant, I am writing outside, 1 plus d by I plus 1 whole square into x. Let us take this to numerator. Real part of e power ix 1 by I plus 1 whole square. By taking this to numerator, we get like this. We get like 2. Okay. Now let us find the particular integral of this one using this formula. We have a formula. This formula says that 1 minus 2x plus 3x square and so on. Now here we write up to first degree term because here x is there. X is of power 1, here degree 1. So this can be written as like this. Real part of e power ix into 1 by I plus 1 whole square 1 minus d by 2 into this one. We will not write the other terms because here x is of power 1. We write into x. Let us simplify this one. Real part of e power ix 1 by I plus 1 whole square. This is nothing but x minus 2 by I plus 1 into derivative of x is 1. We get like this. Now let us simplify this one. If we simplify this one, we get like this. Real part of e power ix into 1 by it is of the form a plus b whole square. So a square plus b square 2ab into ax minus 2 by 1 plus I. We simplify further. This is real part of e power ix into I square is nothing but minus 1. So we can cancel plus 1 with minus 1. So we'll get 2i here x minus 1 by minus 2 by I plus 1. Let us simplify further. This can be further simplified as like this. Real part of e power ix. Taking this 2i inside, we get like this. 2 can be cancelled. We get I into I plus 1. Further you simplify real part of e power ix into x by 2i minus 1 by I square plus I. We know I square is minus 1. So let us simplify further. Simplify further real part of e power ix into x by 2i 1 by minus 1 plus I. Further you simplify by multiplying with I and dividing with I. We get like here I am multiplying with I, dividing with I. Here also I am doing rationalization like that, multiplying with I plus 1, dividing with I. Simplify further. This is real part of e power ix into I is nothing but I square is minus 1, so you will get minus x by 2 into I. Here we get I plus 1 divided by I square minus 1 square. I square is minus 1, so we get like this. Is real part of e power ix into minus x by 2i. Here we'll get minus of I plus 1 by, here minus 1 that becomes minus 2. We get like this. Simplify further. This is real part of e power ix into minus x by 2 into I, minus become plus 1 by 2 plus I by 2. Here minus become plus 1 by 2 plus I by 2. Now write down real and imaginary parts separately. Now this can be written as real part of e power ix into 1 by 2 plus, by writing I outside, we get 1 by 2 minus x by 2. Now this is real part, this is imaginary part. Again e power ix can be written as like this. E power ix is nothing but real part of cos x plus I sin x, using De Mor's formula 1 by 2 I times 1 by 2 minus x by 2. Now this is real part, this is real part. Now this is imaginary part, this is imaginary part. Real and real gives real, real and imaginary gives imaginary, imaginary and real gives imaginary, imaginary and imaginary gives real. So collect only real part. Now finally we'll collect 1 by 2 cos x, this into this, that becomes minus sin x, 1 by 2 minus x by 2. Now this is the particular integral of the problem using this general method. Now finally we write a general solution as required general solution is given problem is complementary function plus particular. Now this gives the required solution of the problem. In this problem we were discussed how to find particular integral using general.
Thank you.